All right, so we're going to look at predicting products for single replacement and double replacement reactions. And so the great thing about this is you guys have access to this presentation in Schoology. So you can look at it as many times as you want. So let's start with single replacement reactions are reactions in which you have an element replacing another element in a compound. It can be cation replacing cation or anion replacing anion. That's single replacement reaction. Think about you making a sandwich and you made a turkey sandwich, but you decided that you didn't really want the turkey, you wanted ham. So you replaced the turkey with ham. So it's like a single replacement reaction. On the other hand, double replacement reactions occur when you have two compounds and it's like they switch places. Okay. It's like you have two friends. Friend A has on a purple scarf, friend B has on a blue scarf, and they switch. So now A has on the blue scarf and B has on the purple scarf. Okay. So that's like a double replacement reaction. All right, so let's get started with what it's going to look like. So a single replacement reaction, you can have several things happening. You can have a halogen replacing an active halogen, replacing a less active one, okay, in a compound. So that would be anion replacing anion. You can have a metal replacing hydrogen in acids, and it will form an ion and hydrogen gas. A metal replacing hydrogen in water, reforming, forming a metallic hydroxide and hydrogen gas. And this came up yesterday when we had lithium replacing the hydrogen in water and forming lithium hydroxide versus lithium oxide. Okay. And then you have metals replacing less active metals from their compounds in solution. And to help with that one, you really need the activity series. And you all have an example of that where the more active elements are closer to the top, okay, and they replace everything underneath them, okay. And lithium, I believe, is at the top of the list. I should have this in front of me. But yes, lithium is at the top of the list and it replaces everything underneath it. Gold is at the bottom of the list. There's nothing underneath gold. So guess what? Gold is not going to replace anything in a chemical reaction. Okay. Um, and then here, I want you guys to work through this problem. You have your activity series for metals and nonmetals. You need to use them and then look at this reaction. You have lead reacting with phosphoric acid. That's H3PO4. So lead reacts with phosphoric acid. If this reaction occurs, if the lead replaces the hydrogen in phosphoric acid, if that happens, a reaction will occur. If that is the case, what are the products? And then balance the equation. So you're going to pause this, work through it, and then you're going to ask me what the answer is in class. All right? So that's single replacement. If we go back, let's look at double. So double replacement reactions, you have two soluble ions in solution may form an insoluble precipitate. We're getting ready to look at those where we're looking at something called the solubility rules, and it lets us know if these two ions come together to form a compound, they will either be soluble, where it will form an aqueous solution, or insoluble, where it forms a precipitate or a solid. Metal sulfides, when they combine with any acid, will form hydrogen sulfide gas and a salt. We looked at these yesterday. We looked at gases. We looked at hydrogen sulfide, carbon dioxide, sulfur dioxide, and ammonia. Okay. And the next bullets talk about that. Metallic carbonates, when combined with any acid, will form carbon dioxide gas, water, and a salt. Metallic sulfites, that's SO3 with a 2 negative charge. So something sulfite, like a magnesium sulfite, that's a metallic sulfite. When combined with any acid, will form sulfur dioxide gas, water, and a salt. Ammonia salts, when heated with a soluble strong acid, will form ammonia gas, water, and a salt. And then an acid and a base will form a salt and water. And then coming up, you should have, yes. So here, it's a double replacement reaction. You have zinc sulfate reacting with lithium carbonate. And what I want to know is which letter choice is the products for that reaction. Okay? And that is just a review of the single and double replacement reactions that we've looked at. And we will continue looking at more reaction types in class.